Let's quickly configure a topology. Uh, so serial 1 by 0, serial 1 by 0, serial 1 by 1, R3 1 by 0. Serial 1 by 0, 1 by 0, 1 by 2, 1 by 1, 1 by 0. 1 by 2, so first of all, R1, enable global configuration mode. Then we have to configure an interface serial 1 by 0. I'm going to divide it into three areas. So this one is one area, this is the second area, this is the third area. So 10.1 networks, 10.2 networks, and 10.3 networks. So I'm just going to configure it. So we can go to global configuration mode, interface serial 1 by 0. We are doing in paint. So IP address is 10.1.12.1, 255.255.255.0, and we will use no shut and exit. So then we copy this, paste and paste again. So serial 1 by 1, so it will become 13.1, serial 1 by 2, 10.2.14.1, and after this we have we'll copy this config and paste on R1. So now we have to paste it for R2. On R2 we have only serial 1 by 0, which is 12.2. Then we will configure a loopback. So we can make it loopback 1, and loopback 1 is, or let's say it is router to make it loopback 2. So 10.1.2.1. So we don't need this interface. So we copy it and paste on R2. So now we paste it for R3. On R3 we have 13.2 and loopback is 3, 3.1. We paste on R3. So then we paste for R4. On R4 we have serial 1 by 0, which is 10.2.14.2. Then we have we don't have loopback, so we'll have serial 1 by 1. So it is between router 4 and 5. So we'll make it 10.2.45.1. Then we have serial 1 by 2. So it is 10.2.46.1. We go to R4 and paste it. Then we have R5. On R5 we have serial 1 by 0. Serial 1 by 0 is 45.2. And then we have loopbacks. Loopback 5. The loopback 5 will become 10.2.5.1. So it will become 1 by 0, and we don't have any other interfaces. So we go to R5. Next device is R6. So on R6 we don't have loopback, so we'll make it serial 1 by 1. So serial 1 by 1 is 10.3.67.1. Serial 1 by 0 is 10.2.46.2. Then I will copy this serial 1 by 1 as serial 1 by 2, and it will become 10.3.68.1. So I'll paste it on R6. Yes, this is the first class for SDA. For SDA, we have underlay ISIS, we have control plane, list, we have data plane, VXLAN, we have policy plane, trust sec. So we have to discuss those planes and packet forwarding first. Then I will show you the configuration. If you guys are not interested in these, we can just go straight forward to the configurations. It will not take 2 to 3 days. The configuration part. So then we have R7. On R7 we have serial 1 by 0, which is 67.2. Then we have loopback 7. So we make it 10.3.7.1. So now we will paste it for R8. So this one is 10.3.68.2, 8.1, 8. So we paste it on R8. So basic configuration is completed. So now we quickly discuss some theory for the ISIS. Just give me a minute. ISIS intermediate system to intermediate system. So basically, when we are talking about OSI routing, so basically ISIS is an OSI routing protocol used to route the traffic for, like IP. There is a protocol which is called as connectionless network protocol, CLNP. So it is used to route the traffic for CLNP. CLNP is used to route the traffic for connectionless network services. So connectionless network protocol. So this is the flexibility of ISIS that we can modify. So basically in the updates, the routes are carried in the form of TLVs, type, length and value. So if we want to carry some new value, new value means some new address family. So we have to develop only the TLV. So REST ISIS core can be used to route the traffic for that as well. So ISIS variant used for the routing of IP prefixes is called as integrated ISIS. So now we are going to study this integrated ISIS. So according to OSI, we have two terms. So the first term is ES. ES is end system. Then we have a second term which is IS. IS is the intermediate system. So end system is your end host. Intermediate system is your router. So when we are talking about this ESIS or ISIS or OSI routing, so we can use this routing for so ISIS or OSI routing levels. The first one is called as level 0 routing. The second one is called as level 1 routing. Then we have level 2 routing. Then we have level 3 routing. So level 2 routing between the end system and intermediate system and is performed using a protocol ESIS, end system to intermediate system. So this one is called as intra-area routing. When two IS intermediate systems belongs to the same area, that is called as intra-area routing performed by ISIS. So this one is again inter-area routing. If two IS belongs to two different areas, so that is called as inter-area routing. So this is performed by ISIS. Then we have level 3 routing between routing domains. So AS autonomous system is called as routing domain. So when we have to route the traffic between different routing domains, so this is managed by or performed by inter-domain routing protocol. It is something like BGP. So these are different routing levels. So we are concerned about level 1 and level 2 routing. So now we will discuss some basics of ISIS. So ISIS is a link state routing protocol used to route traffic within the routing domain or autonomous system. So ISIS administrative distance. ISIS administrative distance is 115. ISIS algorithm is SPF algorithm, shortest path first algorithm. ISIS metric is cost. So by default, each link's cost is 10. So for proper routing, we have to set these costs. So according to our routing policy. So if we don't change the costs, so then it behaves like RIP. The destination with the shortest hop counts. So that path will become the best path. So cost interface metric is 24 bits value. So you can set any 24 bits value for the interface cost. So path cost is a 32 bits value. So when we want to enable this one, so basically we need to understand some very basic stuff. ISIS packet types. The first packet type is hello packet. The second packet type is called as CSNP. The third one is called as PSNP. The fourth one is called as LSP. So these are the four packet types. So first of all, hello packet. So IS is the router. So IS generates the IS intermediate system hello. For end systems, and end system generates the end system hello to advertise themselves for intermediate systems. So then we have a third type of hello which is called as IIH. So intermediate system to intermediate system hello. So is used to establish the neighbor relationships. So ISIS establishes different neighbor relationships at level 1 and level 2. So if two routers are running both levels, level 1, level 2, they will establish two neighbor relationship, one for level 1 and one for level 2. It means this IIH is also of two types, level 1 and level 2. Complete sequence number packet, you can compare it with DBD. So it is used to carry the uh, description of the uh, link state advertisements stored in the topology table. So PSNP is like LSR, link state request or link state acknowledgement. So this is like LSU. So it carries the link state updates or the LSS. So LSP, link state packet, or PDU. Complete sequence number PDU, protocol data unit. So this one is partial sequence number PDU. So this is link state PDU. So link state PDU is used to carry the LSAs. So these are the packet types. In the same way, we have IS types. So one is called as level 1 IS. The second one is called as level 1, 2 IS. The third one is level 2 IS or level 2 only IS. Involve only in intra-area routing. So it is like ABR, area border router. Involves in both intra-area and inter-area routing. So this one involves only in inter-area routing. So ISIS circuit types: L1, L1, L2, and L2 only. So again, it can be used to control the types of the packets. Uh, so we will discuss it now, that how we can manage this. So basically, according to our topology, we are going to divide our network into three areas. So OSPF area is terminated on the interface. ISIS area is terminated on the link. So one router can belong to only one area. It cannot belong to multiple areas. So there is no any restrictions like OSPF. In OSPF, all the areas must have to be directly connected to area 0. So here there is no any such requirement. So any area can be connected to any other area. So when we use OSPF, OSPF is the backbone centric model. So it revolves around the area 0. So all routers must have, or all areas must have to be directly connected to area 0. So when we consider the networks, we have two types of networks. The first type is enterprise networks. The second type is service provider networks. So in case of enterprise, we have data centers. So everything is revolving around or connected around the data center or headquarters. So that's why OSPF is the better choice for enterprise networks, because enterprise are backbone centric model. But when we are talking about service provider networks, so service provider network has to design their transport. Service providers have two types of networks. One is called as distribution network. The other one is called as transportation network. Distribution network is used to distribute the services to the end users, and transportation network is used to offer the services or to carry the services between the service provider locations. So now transportation network, basically if we have, each country will have its own map, or each service provider can have its own design that how they want to carry the services from one part of the country to the other part of the country. So that's why ISIS does not have any restrictions like backbone centric. So you can design the ISIS backbone according to your choice. So that's why for the service provider networks, ISIS is the better option. So we are going to say that this one is area 1, area 2, area 3. So CLNS, connectionless network services. Use NSAP addresses, network service access point. So NSAP address can be up to 20 bytes. NSAP address format is, so first of all we have to put AFI, area format identifier. So basically it will decide that whether you are going to use the private IP or some public. So basically just giving you an example. Then we have to put the area ID. After area ID we will have to put the dot system ID, and then we have ncell. AFI, area format identifier. So area ID is the area number. System ID is like router ID. So represents the IS. Ncell is something like port. port number. Let's say 49. So 49 represents the private address. 0001 is the area ID. Router is 111 is the router, 111 So this is the system ID and 00 and cell. So this address can be assigned to a router. The NSAP address assigned to the router is called as NET, Network Entity Title. So if NSAP address has N cell set to 00 is called as NET. So we have N cell 00. So that's why we can call it as NET, Network Entity Title. So first of all, this one is our AFI, area ID, and NCell. Area ID, system ID, NCell. So if we want to enable the routing on the router, we have to use the command router ISIS. Let's say we go to R1. So we will use router ISIS, and then we have to set the NET 49.001.111.111.111.00. So we have set the NET. So it is something like you set the router ID. So by default, each IS type is level 1, level 2. It means all the routers will establish level 1, level 2. So R1. So R1 involves in inter-area routing and intra-area routing. So that's why it has to be L1, L2. So this one has to be L1, L2, L1, L2. So these L1, L2 are making the backbone. If you have only a L2 as well, so that will be the part of backbone as well. So L2 and L1, 2 routers collectively form the backbone. So L1 routers are used for the distribution network. So now what we can use is we can exit from here. Then we go to interface serial 1 by 0. Then we can say IP router ISIS. So this command will enable the ISIS on an interface. So, but you can see the serial 1 by 0 is only involved in intra-area routing. So that's why we can say ISIS circuit type. So we have three circuit types: level 1, level 1, 2, and level 2 only. So we'll say this is level 1. It means we don't want to send level L2 hellos on this interface. So now we can just exit from here. Then we'll go to interface serial 1 by 1. So we will use the same command IP router ISIS, and it is ISIS circuit type level 1. Now we go to serial 1 by 2. On serial 1 by 2 IP router ISIS, and then the circuit type is level 2. We just want to establish L2 neighbor relationship. We don't want to establish L1 neighbor relationship between the routers in two different areas. So this is how we can configure the routing for ISI. So we'll repeat the same command set on these routers. The next one is router 2. So we'll say router ISIS, then we'll say NET 49.001.222.222 and 00. So we'll go to interface serial 1 by 0. So IP router ISIS. We go to interface loopback 0, IP router ISIS. So sorry, there is no loopback 0. The interface loopback 2 IP router ISIS. So under the router ISIS, we can set the IS type. So IS type level 1. So now we can go to R3. We can say router ISIS, and then we will have to set the NET. So 49.0.0.1.333.333.333.00. So we will have to set the IS type level 1. We go to interface loopback 3. So IP router ISIS. Interface serial 1 by 0. So IP router ISIS. So router 4. So router ISIS. So we have to set the NET. So this router is in area 2. So 49.0.0.2, and then we'll put 444.444.444.00. So we'll exit from here. So then we go to interface serial 1 by 0. So IP router ISIS. Then we go to we have to set the ISIS circuit type level 2 only. Then we go to interface serial 1 by 1. So IP router ISIS circuit type level 1. Then we go to interface serial 1 by 2. So IP router ISIS circuit type level 2 only. So next router is router 5. It is level 1 only. So we go to router ISIS. We have to set the NET. So 49.0.0.2.555.555.555.00. Then we have to set the IS type to level 1. We go to interface serial 1 by 0. So IP router ISIS. We go to interface loopback 5 IP router ISIS. So router 6, we have to use the router ISIS. We have to set the NET. So this router belongs to area 3. So 49.0.0.3.666.666.666.666.00. So we have to go to interface serial 1 by 0. So IP router ISIS, and then we'll say ISIS circuit type level 2 only. Then we go to interface serial 1 by 1. So we'll say IP router ISIS circuit type level 1. So we go to serial 1 by 2. IP router ISIS circuit type level 1. So R7, we can use router ISIS. We have to set the NET. NET is 49.0.0.3.777.777.777.00. So then we have to set the IS type to level 1. We go to interface serial 1 by 0. So IP router ISIS. We go to interface loopback 7 IP router ISIS. Last router R8. So we can use router ISIS. We have to set the NET 49.0.0.3.888.888.888.00. So we have to set the IS type to level 1. Then we will exit from here. Interface is serial 1 by 0. So IP router ISIS. It's okay, no problem, Jim. So we'll just complete this one. After this, we have to use some verification commands, and tomorrow we'll start Lisp. So IS type is we have to set the we have to go to interface loopback 8. We already set the IS type. We don't need to set the circuit type. So IP router ISI. So we have configured it. Now I will show you two routers, R2 and R1. There's some tables. So we can use show ISIS neighbor. So 49 is the AFI, area format identifier. So basically I am deciding by myself. So because I know the format is AFI, area ID, system ID, and NCell. So I'm using area ID according to the design. So this is area 1, this is area 2, this is area 3. Area 1 means 0001, area 2 0002, area 3 0003. So whatever the router number is, I'm using it in the as the system ID 1111.1111.111. So 49 represents the private addresses and cell is 0 for NET. Yes, basically, if you are using over the internet or public, depending upon the scope, you can use 47 addresses starting with 47. If you are using these private, so then you can go for 49. So these are defined. You can just go to IEEE and then you can look for ISIS. You can have a look over there. Otherwise, on the Cisco website, you can find for uh, ISIS configuration in ISXE. So now we use the command. Okay, we were on R2. So we show ISIS neighbors. So it show you the system ID is R1. So type is level 1. Interface is serial 1 by 0. The IP address is 10.1.12.1. So this is the IP address of the neighbor. The state is the hold time and circuit ID. If I change it to show CLNS neighbors, so then it will show you a little bit different information. R1 serial 1 by 0. Instead of IP address, it is using subnetwork point of attachment. Subnetwork point of attachment, if it is Ethernet, then it is your MAC address. Otherwise, it is the HDLC protocol, whatever your encapsulation is. State is up, hold time, type 1 protocol ISIS. If we use show ISIS database, so this is the topology table. So we have R1, R2, and R3. So IS type is level 1. It does not carry the LSA of other routers. So LSP sequence number, it is something like OSPF sequence number, checksum, hold time, it is LS age, and then attribute. So R1 is advertising the default route into this area. So basically you don't need to configure the stuff. Each area type is by default stuff because it is using two different databases to manage the L1 and L2 topologies. So if we use show IP route, so now you can see that our default route is automatically injected by R1 because R1 is L1 L2 router. So that's why L1 L2 router injects the default route into its area. So we have learned this network standard 1.30. So circuit ID is represents to every circuit. Link is called as circuit. So the link between R1 R2 that is called as circuit. So if you remember OSPF version 3 class, in OSPF version 3, OSPF is also assigning the circuit IDs or link state IDs to the circuits. So basically, again, it, right now, let me have a look here on R1, then I can answer it. Basically, it depends upon the show IP ISIS neighbors. So 0001, it is not same all the times. It depends upon whatever the circuit is. Like in OSPF version 3, it assigns circuit IDs start from 4, 5 for the physical interfaces, serial interfaces. So 1, 2 is for Ethernet interfaces. So for the loopback, it starts from something 10 onwards. So in the same way here it is using the first circuit, the lowest interface name and ID that is 00, then the next one is 0 by. So but again it is showing you R2 serial 1 by 0, 1 by 1, 1 by 2. It is showing the circuit IDs for these circuits L1 and this is L2 for L2 again 00. Show ISIS database. So we have separate database for inter intra-area routing and inter-area routing. For intra-area routing, we have 1, 2, 3. For inter-area routing we have 146. So if we use show IP route, so now you cannot see any default route here because it has all L2 routes. Because this router is not injecting any L2 routes into that area, that's why it is advertising the default route. So if we want to establish connectivity between the loopbacks of these routers, so you can take a trace route 10.3.8.1 and we want to use 10.1.2.1. So it goes to router 1 to router 4, router 6 and router 8. So we can communicate end to end. So we have this default route. Using this default route, this router will send the traffic for the prefixes which are missing from the routing table towards the L1 L2 router. So L1 L2 router will send that to the next L1 L2, or maybe that is only L2. So then that one will send it to L1 L2. So the benefit is, so why we are using ISIS as the underlay? Because if we have multiple paths between two access layer switches, so instead of, so one path is blocked by STP. In the same way, we have to configure FHRPs. We have to do all those configurations. So right now, if we have multiple paths available, we can use the equal path cost load balancing or equal cost multipathing. So we can use all possible interfaces between two border nodes to communicate to each other. So this is the benefit. That's why uh, ISIS is used for the routing of IP addresses and even MAC addresses. So when we will discuss those things, so then we will see that how communication is happening on the SDXS. But replacing the uh, layer 2 with layer 3 routing, or layer 2 switched network with layer 3 switched fabric. So the main benefit is all the links can be utilized at the same time. All the paths can be utilized at the same time between two edge nodes or two access layer switches. So just,
Hi, Sakib, one question here. So basically, the idea is to stop using STP, is it? That is the aim.
yes, it is.
Oh, okay, okay,
So we don't want to go for,
okay.
we don't want half of the links to be blocked for one VLAN or for the other VLAN. So now
Mm-hmm.
we have our VLAN is terminating on these access layer switches.
Mm-hmm.
So then if we have to communicate between two systems in the same VLAN connected to two different devices, we will be using VXLAN. So we will map the VLAN ID with the VXLAN ID. So anyway, so when we will proceed further, so after this we will see list. In the list we will see how we have to find out the OR logs for the endpoint identifiers. So that information will be used by VXLAN. So after this, next step will be Lisp. So tomorrow we'll cover Lisp and hopefully we will cover VXLAN as well. And then if we want to control the communication, so policy, so that policy is through Cisco TrustSec. So if you understand how the communication is happening on the SDXS fabric, we can very easily deploy it. So it's GUI, so we just have to design the network, we have to provision the devices, and we have to define the policy. That's it.
Sakib, is it mandatory to have IP address on all the interfaces while we are establishing ISIS?
No, it is not required.
Layer 3
Sak-
communication is not.
So basically, we will be advertising loopbacks. So we'll discuss that part when we will reach there. Right now, because here we cannot use that option, so that's why we have assigned the IP addresses to all interfaces. So it will be something like your OSPF version 3.
Can you repeat that your comment once, like why the difference between like why enterprise is most involved with the OSPF and why the ISP is on the ISIS?
Basically, in enterprise networks, branch offices have to communicate with data center or headquarters. So that's why we can call it as it is a backbone centric model. So OSPF, in OSPF we have area 0, and all the areas must have to be directly connected to area 0. So we can design that backbone area somewhere around data center, or so that's why all they have to access the services. So OSPF is a backbone centric model, and enterprise is also backbone centric. But when we are talking about the service provider networks, so these service provider networks are basically they design their backbone according to their requirements. Let's say they have some links connected to the next city, then next city, then next city. So basically, in service provider, we divide the networks into two different networks. One is the distribution, the other one is the transportation. So we are using ISM on that transportation network. So we can design our backbone according to our requirements or our physical network design. So this is the flexibility of ISIS. OSPF does not give us that flexibility. Is it?
So, Saqib, for the SDA, is it mandatory to use the ISIS, or
It
we
is
can
not
use any
mandatory.
other
You can
under?
use OSPF. Even you can use
Okay,
the routing protocol. But recommended is ISIS. The benefit of using ISIS is ISIS can carry the prefixes or can carry the addresses of different address families. OSPF is for IPv4 or v6. So it can carry different service. Let's say in all latest Cisco technologies, like we are using Cisco Cloud, we are using Fabric Path, no, not using anymore. So whatever the new technologies, they are based on ISIS. So we are routing different address families using ISIS because ISIS LSP carries the prefixes in the form of type, length, and value. If you want to perform routing of some new addressing, you just have to define a new type. You have to define the length, and you will have to it, then it will be able to carry that values. So ISIS is
got it. Thank
flexible than other protocols.
Got it.
Saqib, do we need to manually configure the ISIS
No,
or
we
it is
don't need to.
inbuilt,
It
it is
will be
configured?
provisioned automatically. So we have both options, but usually we don't configure manually. But at least you have to you have an idea that how ISIS works. What are the addresses we have assigned to these devices? So basically, sometimes again you will not have to do this, but when we go some more deeper, sometimes we need this understanding to troubleshoot different issues. So right now we are not having so many intermediary devices, so that's why we will not be facing those issues. We will have just connected then. So anyway, we will discuss that part later on.
Saqib, so when you are going to upload this video of today's class, because I was joined late, so I want to just see
I will
the
just
first.
forward it now. I will just forward it now within an hour, and in the morning, hopefully, NetMet staff will upload this video.
Okay, so and where it should be uploaded in the June batch, or how, or where this
I
class
don't know.
video will be there?
Basically,